So here's the analysis. In Desmos, notice this is my account. You're actually going to use this particular one here, but don't worry, as you're not saving it to my account, you're not messing anything up there. Perhaps the most important one is right here. This is where it says share graph, and you get this one here. When you're done, share this link. So you just click it and you copy it, Control-C, and then you paste it into the lab report, and then I have it. And notice that this link here will be unique. You see the B5SQ here at the end? Let me just get out of this here and let me just do something. For example, just shift this one around here, and let's see if I click to share. Notice totally different link. So whenever you do something, it will actually change. I would recommend that once in a while you kind of like take that particular link and just paste it somewhere in there so you're not losing the work that you already did. All right, so let me show you. Oops. Oh, great. How did I do that? Oh, I opened a new window. All right. So here are my example data that you had already seen in the lab manual. So increasing charging and then topping out, that's this curve here, and then decreasing during this charging, and then it bottoms out here, so that's exponential curve. And not only are the data on here, but you also see the regression curves, the exponentials that are apparently really close to the data, which means I took really good data, and turns out that if you were to do the experiment, all students always take very good data, because the only error source that you have is the multimeter itself measuring the voltage, and of course the timer here, and it really doesn't matter if you're off by a few tenths of a second. Anyway, this one looks a little bit off screen here, so I'm going to scroll down a little bit, and there's a little plus sign right here on the table, and now it puts it nicely back into the window so we can see it. So I got the data here. You can see them over here. By the way, if I click these here, just click, and the data are gone, right? Okay, right beneath it I have these equations. This one here is a typical exponential with the negative, meaning that it decays, so it goes down and down and down. That's the discharging one. Again, when I click this one here, there, it's gone, right? And then this one here is 1 minus the exponential, so that's kind of like mirrored. I think you can see that the charging one is a mirror image of the discharging one, and it goes to zero, goes through zero, because it apparently starts at 0 voltage when it's being charged. And so both of these describe these data. All right. So let's look at the numbers over here. There is an R² value, which means that's how good the regression is. Notice I have a 0.9999, and that means my regression is virtually perfect. Same thing over here. There's a second number here, the voltage, that's kind of like the top voltage, 2.74, and the other one is 2.30. That's where it tops out. I actually don't need that. The only number that I need is this tau here, which is the time constant. So this one here says 74.5. I will use that. And this one here says 78.1, and I also will use that. And you see it in the equation. It's right here. The tau right here and the tau right there. So I will go over to my lab manual and use these numbers. And so apparently the 74.5 rounds to 75, and the 78 point something, I think it was 78.1, that should round to 78, not 79. There you go. All right, and then using these time constants, I will compute the capacitance, the total capacitance. So I'm going to do 75 divided by the resistance. The equation is right here. Capacitance equals time constant divided by resistance. In this case, I used 99,000. So there we go. Come up with this number here. This is in farad. Notice that it's a small number. In order to get into micro-Farad, well, micro is 1 millionth, so I'm going to multiply with 1 million. There we go. And I come up with 757 micro-Farad. I want to use 2 sig fig, so 760. I'm not sure exactly why I previously wrote here 800 as if it was just 1 sig fig. It ought to be 760. And that's based on that my times here are pretty much 2 significant figures, right? These are not around at 90. I really tried for 90 seconds, not 89. So I would actually have 2 sig fig. All right, the other one is, I'm going to do 78 divided by that. There we go. And again, multiply by 1 million. Keep hitting the second entry button. That's really nice on a TI calculator. And I come up with 790 microfarad. And notice my results as compared to the expected one is actually really right on and justifies that capacitors in parallel add up their capacitances, which is unlike resistors, which would add their resistances if they were in series. So capacitors in parallel do the same thing as resistors in series. Okay, so second time as a charm, it actually worked. I did film it correctly. So now I'm going to switch to the second capacitor. So the first one is supposed to be 1500 microfarad. Of course, that's what the experiment is about to determine that. And the second one is supposed to be 2200 microfarad. So I'm going to put that one in and hook it up again. Just going to see. I want you to ignore the negative there. Oh, connect. And so I will switch these around. So I'm not measuring just yet. I just want to switch it in such a way that we can ignore the negative. All right, ready to measure. And switch on. Timer starts. Timer starts. There you go. And again, measure every 10 seconds, such as right now. And I will actually read my book, Der Wüstenplanet. Wo ist Alia? Fragte sie. Sie ist draußen, sagte Paul, und sie tut das, was jedes echte Fremdkind in solchen Zeiten tun sollte. Sie tötet verwundete Gegner und markiert ihre Körper für die Teams, deren Wasser einsammeln. Paul, du verstehst hoffentlich, dass sie dies lediglich aus Mitleid tut, fuhr Paul fort. Es ist nicht seltsam, wie oft wir vergessen, dass Mitleid und Grausamkeit einander so ähnlich sind. Jessica starrte ihren Sohn an. Die unerwartete Veränderung schockierte sie. Ist der Tod seines Kindes daran schuld? Fragte sie sich. Dann sagte sie, die Menschen erzählen sich seltsame Geschichten über dich, Paul. Sie behaupten, du hättest alle Kräfte der Legende, dass man nichts von dir verbergen könne, dass du alles siehst, was anderen verborgen bleibt. Sollte einem Bene Gesserit solche Fragen stellen, erwiderte Paul. An allem, was du bist, bin ich nicht unschuldig, sagte Jessica. Du solltest also nicht. Wie würde es dir gefallen, Milliarden und Abermilliarden von Leben zu leben? Entgegnete Paul. Sie würden eine ungeheure Sammlung von Legenden für dich mitbringen. Denk nur an die unschätzbaren Erfahrungen und die Weisheit, die sie mit sich bringen würden. Aber Weisheit kühlt die Liebe ab, nicht wahr? Und umgibt jedweden Hass mit einem neuen Kleid. Wie kann man sagen, was Unbarmherzigkeit ist, ehe man nicht alle Tiefen der Grausamkeit und des Mitleids ausgelotet hat? Du solltest mich fürchten, Mutter, denn ich bin der Quieser Zaderach. Jessica schluckte. Ihre Kehle war wie ausgedörrt. Plötzlich sagte sie, es gab einmal eine Zeit, da hast du mich wegen dieser Tatsache abgelehnt. Paul erwiderte Kopfschütteln. Ich bin jetzt nicht mehr in der Lage, irgendetwas abzulehnen. Er sah ihr in die Augen. Der Imperator und seine Leute werden bald kommen. Man wird sie jeden Moment ankündigen. Bleib bei mir, ich möchte sie im klaren Licht sehen. Meine zukünftige Braut wird ebenfalls unter ihnen sein. And take the last measurement now. All right, getting ready to discharge this capacitor. Gonna turn the switch off now. Stop the timer, reset the timer. At least I'm trying. Oh, what did I do? There we go. All right. Okay. disconnect the battery, close circuit again for discharging, and turn the switch on and start the timer. Again, it's never crucial that the two are at the same start at the same time, because you're not measuring the 0 point. Alright, and take the last measurement right now, or 1 second before that. Alright, got the second capacitor done. Alright, these are the two capacitors in parallel, and I'm going to start the charging and timer. And measure now. I just closed the door because there was some noise from the outside. You also see that I'm using a different setup. Measure now. And that was mainly, I do this a few days after the first ones. Measure now. Because I wasn't quite satisfied with the result from the first data. The data were great, but the result were just quite a bit off. Measure now. I also noticed that the display of the voltmeter wasn't all that great. Measure now. But that was because that was the first thing I filmed, the spring, and then I filmed the Ohm's law later. Measure now. And that's when I noticed that, oh yeah, you know, it's a little bit in the dark, it's hard to see the decimal point, but since you're going to do the Ohm's law first, you probably figured that out, that what you're reading right now is 1.3 something volts. Measure now, 1.42 volts. So I don't think it's a detriment because you're already used to looking at the voltmeter. But in any case, the main reason was that I didn't like the first data. It was just a little bit too off for the discharging. And this, of course, is the charging part. Those that actually were fine, so I'm redoing them anyway because I have to charge it up anyway. And then I'll see what happens with those. I wonder if you actually see these lights or rainbows going across the table. I put some diffraction gratings in this little side room here. It's kind of like a little tiny conference room. This should be the last measurement now. And so I'm going to turn this off in a moment. Yep, I'm going to turn it off now. Stop the timer. Reset the timer. Leave the voltmeter the way it is. Get the discharging part set up and start the switch, start the timer, and it discharges. Yeah, so I put some diffraction gratings in this room here so you get rainbows in certain areas, and hopefully you measured 3 seconds ago. So let's see, measure now, and I'm gonna see if you can see these rainbows in the room here, kind of floating around. Ooh, I better get back. Measure now. I'll try it again in a moment if it doesn't bother you too much. Measure now. There they are, here they are. Better get back. Measure now. They're kind of all over here. That's kind of pretty. Okay, I'll stop doing this. So I finished the novel Wüstenplanet, Frank Herbert's Dune. It'll be in the movie theaters later this year. So I have to figure out what's the next one I'm going to read. I have this climate change novel here called New York 2140. So anyway, and there are the data. And finally, 2 capacitors in series. I'm going to reconnect the battery, make sure that the switch is off, and might as well discharge them right here. There we go. Okay, I have to do a little bit more work on this one here. The other one was really easy to set up. This one isn't so tough either. But here we go. This is a little tough of a board here. There we go. Got all connected, so they're all in series with each other, including the resistor, of course. Alright, so I can hook up the voltmeter. In this case, I have no choice. I cannot measure here. I cannot measure here. In fact, if I turn it on, there we go. Now I'm measuring only one capacitor. Here I'm measuring only one capacitor. And here actually I'm measuring nothing because I only have a wire in between. So it has to be over here. And again, I'm going to turn this one off and discharge the two capacitors in series. And you already noticed that this goes very fast. They're charging up very fast. So I'm only going to do 100 seconds instead of the 150 that I used to. And why is it discharge again? There you go. All right. So turn the switch on, turn the timer on, and start measuring very soon here at 10 seconds. As you can see, it goes up quite fast. Measure right now. Alright, and take the last measurement right now, because that's when the 100 seconds are done. And notice it actually barely at all goes up anymore. So I'm going to turn this one off, unhook the battery, and get a closed circuit again. Reset the timer. There we go. And start discharging. Again, it goes down quite rapidly at first. Right now. Alright, and take the very last measurement right now. Okay, again, I always let it run a little bit longer, and we're finally done with this experiment. Took me in the neighborhood of close to 3 hours to film all this, and I think the total footage is in the neighborhood of 25-30 minutes or so. Alright, and then I still have to edit it actually. So, there we go.